All right, this is video 12C. We're going to be learning about the atom. So for any of the announcements on the assignments or any announcements, just check that introductory review video. So the big question for today is, how can we see something too small to see? So let's look at the weekly plan. Just a reminder, Monday, it's going to be some introductory notes and videos. The Tuesday, Wednesday will be lessons. Thursday will be try to be lab day, and Friday will be any miscellaneous things that we missed and time for that homework. But it is subject to change because sometimes things need to be taught or the labs need to be done first or something like that. Now, every week there will still be the following assignments: a lab activity, a homework, and the notebook check will be on that homework assignment. So remember, there are codes in the videos. One will be written, one will be verbal. Each code will be 3 numbers. You'll need all these codes in order to move on with that homework assignment. So write what's in green, right? That's what needs to be in your notebook. So the video 12C written code will be 253. So that's the written code. I recommend writing that down somewhere. So this video will help describe what an atom is and the history of it, and what the word atomos means, which is where we get the word atom from the Greek word atomos, which means uncuttable. So I used to do so if you want to do this at home, you can do the Atomos challenge. The challenge of this task is to be the group that can cut your strip of paper in half as many times as you can. Each group will be given a strip of paper and scissors. So one person in the group will be cut the strip paper in half as many times as he or she can, and just clean up after the challenge, right? So um, now, if you see here, you'd have to cut it. Most of the time, you can get from about 7 to 10 cuts. 10 is really, really small, um, but you'd have to cut that paper in half 31 times in order to get down to the size of an atom. So Democritus was the first person that proposed the idea of atomos, or something that's uncuttable, in the year 400 BC. So he proposed that atoms are infinite number, uncreated, and eternal, and the qualities of an object results from the kind of atoms that make up it. So he proposed, hey, there's different kinds of uncuttable things. Now, John Dalton, about 2,000 years later, in 1803, he introduced the sphere model. So he proposed that atoms of different elements have different properties like mass. He also proposed that atoms rearrange during chemical reactions. This is kind of a big deal because he did this in 1803, and he was able to identify several different types of elements, different atoms, before the periodic table was even put together several decades later. So J.J. Thomson was the one that he discovered the electron in 1904, and he introduced the plum pudding model. He just said, okay, well, I've got this positive charge at some point, so I think it's just some kind of a pudding substance, and inside of this pudding is going to be the electrons. And he did that with the cathode ray experiment, which he was able to strip parts of the electrons off of what he thought to be atoms, and then he will put a magnet close to it, and it bent. And he said, well, this has to be negatively charged based on how it bent. Now, Albert Einstein, he didn't propose a new atomic model, but he used Brownian motion to measure how big atoms were. So, now, Brownian motion in 1827, while examining grains of pollen, uh, Brown, he noticed that this pollen moved around like this random scattering. That's called Brownian motion. And Einstein came along and he was able to calculate how large atoms were based on this motion. Now, this is a video on Brownian motion, and you can see this if you just drop colored dye into water. Well, that Brownian motion, the movement of atoms, is what disperses that color. And if you in this video, you can see the cold one, hot one. The hot water will disperse that colored water a lot faster because, well, the molecules are moving faster. Now, Ernest Rutherford, he's discovered the proton. He introduced a nuclear model in 1911, which he proposed that the positively charged particles were located in the center of the atom. He did with his gold foil experiment. You can see that in that simulation. So how can we see something too small to see? What's a gold foil experiment? And this video shows what that gold foil does, what that gold foil experiment was. What happens was he shot alpha ray particles at a gold foil, and he thought that all of these rays should go through, but some of them deflected. About 1 in 8,000 deflected and hit somewhere else. So he proposed that there has to be something small, something dense in the middle of an atom, and it has to be positively charged. So he discovered the proton. So we're going to do that gold foil experiment. It's just like hitting, it's going to be just like air hockey, where you're going to be hitting pennies at masses, and you're going to measure the size of these masses without being able to see them. All right, and that brings us to 1913 with Niels Bohr, who introduced the planetary model. Now, he advanced the theory that electrons travel in orbits around the nucleus, and the electrons in the outer orbits, or those valence electrons, determine the atom's chemical properties. And then Schrodinger came along and introduced the quantum model in 1926. And you've probably heard of Schrodinger's cat. So he sort of proposed that, well, the electrons don't orbit around. There's a probability that we know about where the electrons are, but we cannot tell for sure. And he just sort of introduced us to the quantum world where things get kind of weird at that small level. If you want to learn a little bit more about Schrodinger's cat, there's a quick video. And this is like the history, right? This is the history of the atoms, theories, and models. So you all know the parts of the atom, right? The nucleus is the center of the atom. It contains the protons and neutrons. The electron cloud is the area surrounding the nucleus where electrons are found. The proton is positively charged particle in the nucleus. The neutron is the neutral particle in the nucleus. The electron is the negatively charged particle located in the electron cloud. All right, so we're gonna do build an atom simulation in which you take protons, neutrons, and electrons. You're gonna put them there. You're gonna see how that affects the element, the net charge, and the mass number. You're gonna answer some questions based on that. So let's talk about how to identify an atom. Now, the atomic number identifies the element. It's just a number of protons. So that's this bottom one right here. So this is sodium. Every sodium atom is going to have 11 protons. The mass number is the number of protons plus the number of neutrons. So this mass number right here is 23. That means at the center of every single sodium atom, I'm going to have 23 protons plus neutrons, 23 objects in the center. Now, the charge is the overall charge of the atom. Right, so there's a positive one up here. Well, that's just going to tell me how many electrons I'm going to have because this is an ion. It's an atom with a net charge. Now, an isotope has the same number of protons, different number of neutrons. It's the same element, though. So let's go over some problems here, right? So let's look at lithium. Now, the atomic number is going to be 3. That's the bottom one. Now, the mass number is going to be 7. Now, this atom is going to have 3 protons. That's the atomic number. It tells me how many protons it has. It tells me what element it is. How many neutrons does the following atom have? Well, I know that I have 7 protons plus neutrons in the center of that atom. And I know 3 of them are protons. So 4 of them have to be neutrons. Now, the net charge of this atom is going to be 0. So what that tells me is that I have the same number of protons as I do electrons. So if I have 3 protons, I have to have 3 protons, 3 of those positive charges. I have to have 3 electrons, 3 of those negative charges. All right, now problem number 4. Let's look at this one. So now we have an ion. So the atomic number for this is 19. This is potassium. So that's what determines the element. The mass number is going to be 39. I have 39 protons and neutrons at the center. So this is going to have 19 protons. That's the atomic number. That's what determines what element it is. Now, it's going to have 20 neutrons because I have to take 39 minus the 19 protons, and I get 20 neutrons. Now, what is the net charge of the following atom? It's going to have a net charge of positive 1. That means I have 1 more proton than electron. So if I have 19 protons, I'm going to have 18 electrons because electrons are negatively charged. I have to have 1 more proton than electrons. So it's going to have 18 electrons. So now let's talk about isotopes. So if we look at carbon isotopes, I've got carbon-12, carbon-13, and carbon-14. All of these carbon atoms are going to have 6 protons. That's what makes it carbon. Now, how many neutrons does carbon-12 have? Well, it's going to have 6 neutrons. 12 minus 6. That's 6 neutrons. Well, now carbon-13, 7 neutrons. Carbon-14 has 8 neutrons. Right? So that is what an isotope. Now, how common are isotopes of different atoms? So most atoms have different isotopes. So we already went over carbon. Notice that carbon-12, that's the most common form. You got some 13, and then there is a little bit of 14 as well. Now, look at silver. So if you have a silver necklace, it's split about half and half. Silver 109, silver 107. Now, chlorine, that's about 3/4 are going to be carbon-35 or chlorine-35, and then about the other half are going to be chlorine-37. Now, mercury has a lot of different isotopes, so it's sort of all over the place, but these are all stable isotopes. I mean, some of them might be decaying, but they're pretty much stable. It's just same element, but different number of neutrons. So this is how isotopes can be used. So if you watch this, this is a good video that shows how the nuclear bomb helped us identify painting forgeries. So periodic table, that's it. The periodic table is complete when number 118 was found, Oganesson. Right, but this video shows how, well, maybe not so much, right? So at this time, I'm going to give you the 12C verbal code. The 12C verbal code is 470. I say that again, the verbal code is 470. So there's the links for the day. Notice that I have a lot of videos, some I didn't even show. There's some activities and some additional resources, and there are the 2 labs that we are doing. And just as a final thought, remember there's just too much unknown in the universe to take a break from learning. Get out there and question everything.